Okay, so I'm going to do a couple homework problems here to help you out with the weekend assignment. And this problem here, number 26, says the terminal side of theta is on the line y equals 1/3 x in quadrant 3. Find the values of the 6 trig functions. And the quadrant 3 ends up being a big hint because if you graph this line, and let's just do a few ordered pairs to get a straight line graph. So if I let x equal 0, 1/3 times 0 is 0, y is 0, so there's 1 point. What if I let's be picky about our points, pick nice points. What if I pick x is 3? 1/3 times 3 is 1, so y is 1. Let's do another easy one. How about 6? If x is 6, do you know what y is? Hope you said 2, right? 1/3 of 6 is 2. So plot these points. 0, 0, 3, 1, 6, 2. All right, if I sketch the line that goes with those 2 points, it goes up this way, and also you know that it continues down this way, right? Do you remember how to name the quadrants? That's quadrant 1, 2, 3, always with Roman numerals, 4, quadrant 4. So find the terminal side of theta is on the line y equals 1/3 x, so now I have the line in quadrant 3. So they want us to look at in quadrant 3 a triangle so that I can find the 6 trig functions of that triangle. So if I do this very little triangle here and then list the sides of that triangle. Do you know what the sides of that triangle are? Well, if this one is over 3 up 1, then this one could be, let's get my line a little bit better. I would go over 3 down 1, so this would be -3, this would be -1. Do you agree with that? So let's draw out that right triangle here. So there's the theta. This is -3, this is -1. I need to find this missing side. You know how to find the missing side? Pythagorean theorem, it comes out to root 10. Do I call that positive root 10 or a negative root 10? Hypotenuse on all the triangles, no matter what quadrant, is always going to be positive. So now it's pretty easy to do the 6 trig functions. Remember, I always want you to write them in this manner. Sine of theta, cosine theta, tangent theta, and then over here, cosecant theta, secant theta, cotangent theta. Why do I like them in this sort of grid? Because reciprocals are right beside each other. So, the sine of theta in this picture, sine is opposite over hypotenuse, -1 over root 10, which of course is negative root 10 over 10. What's the cosecant? Root 10 over -1 or negative root 10. What's the cosine? The cosine, adjacent over hypotenuse, -3 over root 10. I'll say let you do the rationalizing. What's the tangent? Opposite over adjacent, so -1 over 3. And of course these are the reciprocals. I'm going to leave that for you to figure out, but that's how to do the 6 trig functions of a line. You usually need to have the hint of what quadrant the line is in. If I have a line this way, it could be in quadrant 2 or quadrant 4, and the sides are positive or negative based on the quadrant. For example, if these answers would not be the same if I wanted quadrant 1 answers. I'd have all positives. So pay attention to what quadrant you're in when you do these. All right, next question, number 32 on 387. Evaluate the trig function of the quadrant angle. So I only want the value of the secant of 3 pi over 2. I am not as, I don't do secant as easily as I do its partner function, cosine 3 pi over 2. So I'm going to do cosine 3 pi over 2 and then just put the reciprocal for the answer. So first of all, the quadrant angle means that it ends up exactly on one of the quadrant lines. Now, remember that the quadrants are named 1, 2, 3, and 4 with Roman numerals. But 3 pi over 2 is where, all right, if this is 0, this line stands for pi over 2, this stands for pi, this stands for 3 pi over 2, and then this would be 4 pi over 2 or 2 pi. 2 pi and 0 are at the same point. So I need the trig functions of this angle here. So what I do is I think of an angle almost at that line. All right, I'm going all the way. I'm really going to 3 pi over 2. But I need to get a sketch of that angle. If I'm doing a trig function, I need to know the sides of the right triangle. So here's the theta, this side, and this side. All right, I need to know what those sides are. The hypotenuse I always call as 1 because we're thinking using the unit circle. Now, as this angle gets bigger, this side ends up getting closer and closer to the line where 3 pi over 2 is. In fact, when the angle gets all the way, the hypotenuse ends up being right on that line. So the hypotenuse is on that line, and then the side opposite is on that line. So this side here, which is -1, ends up also being on that line. This side here ends up being 0. So I like to draw a picture of the angle almost at that line, and then I try and figure out what the sides are. So the cosine of this particular, it's really a non-triangle because you can't have a triangle with a side of 0. But the sketch of the non-triangle is helpful when you're trying to figure out one of the trig functions. So if I want the cosine of this theta, I know that it's adjacent over hypotenuse, so I know that it's 0 over 1. The secant is the reciprocal of that, so that would be 1 over 0, which is undefined. And there's the answer for 387, number 32. So when you're doing the quadrant angles, whatever angle you have to do a sketch of a non-triangle almost at that point so you can figure out which side is 0 and which side is 1. And then you have your sketch of your hypotenuse, your adjacent and opposite sides to get the values. So there's the non-triangle drawing method to get those. You can double check them on your calculator, but if I say not to use your calculator, then you need to have some sort of sketch to show your work. Good luck on these. Okay, find the reference theta. All right, in number 38 on 387, they tell us that theta is 309. Find the reference theta. And this is the notation. So theta with a little mark there means reference theta. Now, 2 requirements for a reference theta. It's always positive and it's always acute. So the first thing to do is do a little sketch here and show where is 309. And 309, well, this is 270 here, so 309 is somewhere in this quadrant here. So there's 309. Now, when you're finding the reference theta, always think of dropping the perpendicular to the x-axis. So we want this theta here. So if I go all the way, I go to 360. So what's the difference between 360 and 309? 51 degrees. Now, you always want to use the reference theta to the x-axis. We don't want to use this other amount here that's to the y-axis. So always measure reference theta to the x-axis. And just remember that it's always positive and it's always acute. I sometimes use this notation, theta reference like this equals 51 degrees. But those are pretty easy to do using your calculator, so good luck. Okay, find reference theta again. This time we're trying to do this in radians, so if you think of the grid again in terms of radians, this is pi over 2, this is pi, this is 3 pi over 2, this is 2 pi, it's also 0. So 7 pi over 4, where is that? Well, here's a little hint. 3 pi over 2 is the same as 6 pi over 4, common denominators, right? So 7 pi over 4 is in the 4th quadrant. So what's the theta reference? Well, how about 2 pi take away 7 pi over 4? Find the amount left, right? Always measure it to the x-axis. So let's get common denominators here. So 8 pi over 4 minus 7 pi over 4 equals pi over 4. So theta reference, pi over 4. Is pi over 4 acute? Yes. And is it positive? Yes. So remember, reference theta, always acute, always positive, and there's the notation. You can do these. Good luck.